warm welcome to this video lecture series in which we are talking about that how we can improve and optimize our neural networks. So this is the very first video lecture in this series, and in this lecture we are going to see that how we can effectively split a data set between a training set, a cross validation set or a development set, and a test set. So let us continue with this video lecture. So as we have already studied in the previous video lecture series, where we have seen about neural networks and deep learning, that there are various parameters or hyperparameters that can be effectively tuned in order to optimize a neural network. So some of those parameters that we need to see are as follows. The first parameter that can be tuned is the number of layers. So you can adjust the number of layers according to the neural network, and the performance of the neural network would vary accordingly as the number of layers in the neural network changes. Similarly, for each layer, you can have the number of hidden units as a variable quantity. So with increased number of hidden units, it may be possible that the neural network would perform very effectively for that. Similarly, you can tune the learning rate also, but it is often told to us that the learning rate that we have taken should be taken very small initially, and then after that we should increase the learning rate according to the situation. Similarly, we have the activation functions. We have various kind of activation functions, and so according to the work of each and every activation function, we can vary the performance of a neural network. Okay, so suppose that we have an activation function as a sigmoid function. So it is often recommended that in the outer layer, if it is a problem of binary classification, then you should use the sigmoid function in the outer layers. Whereas it is also possible that you can use the sigmoid function to the hidden layers also, but people often tend to use some functions, activation functions like ReLU functions for the inner units. Okay, so these are all 3 to 4 types of hyperparameters that are listed over here. There are several other parameters also that you can tune effectively in order to optimize the performance of the neural network. Okay, now let us move to the next slide. Okay, so this is basically the neural network or a basic machine learning development cycle. In this cycle, you can see that there are 3 phases. The first phase is the idea phase, the second one is the code phase, and the third one is the experiment phase. So the idea phase is the first phase, and here we suppose take an idea and we implement it on our neural network or the machine learning algorithm. We take a specified set of hyperparameters and we take some random initialized values of these parameters, and using these parameters we train our learning algorithm, and based on this algorithm we get some output, and then we basically see that how much efficient output we get using a particular set of parameters or hyperparameters. And then finally we do some experimentation, and we then finally analyze the results of the experiment. And then if we see that the model is accurate, then nothing is to be done. But if we see that much tuning can be performed after this also, then again we can have some new idea. We can tune the parameters, we can change some of the values, and then again we need to code, and then we need to experiment that algorithm. And in this way, this development cycle of any machine learning algorithm goes on. Okay, and this is a continuous iterative process. Okay, now let us move to the next slide. Now Here you can see that basically we are having a data set, okay, which is represented by this rectangle over here. And now I'm going to tell you that how we can effectively divide this data set into three data sets, like training data set, a cross validation data set, and a test set. Okay, so what we generally do while dividing this data set is we split it into the three halves. Okay, so generally the training set is of much larger size than the development set and the test set. So let us take as this as the size of the training set, this as the size of cross validation set or development set, and this as the size of test set. Okay, so I'll write here that this is the whole data set and this is the training data set. Okay, this is the training data, this is the cross validation, so this we called as hold out cross validation, or we often call this part as development set. So instead of writing the whole development, we would generally use the term as dev set for representing this development set. And now the third part of this data set would be the test set. Okay, so these are all the three splits of the whole data set. And now, when we were deploying machine learning models in older days, it was generally advised to us that a split of 60, 20, and 20 would have been appropriate for splitting the whole data set. So, what we generally have is we have a whole data set and you split this data set in the ratio of 60 is to 20 is to 20. Okay. So suppose you have a small data set of say 100 training examples. So 60 would be the training data, 20 would be the cross validation data, and 20 examples would be in the test set. Okay. And what is basically the significance of training data, the cross validation, and the test data set is basically you train your model or the learning algorithm based on the data that is given in the training data set. And the use of cross validation data set is that suppose that you have a series of learning algorithms, or suppose that you tune your parameters or make 3 to 4 models of the using the same training data. Okay, and now you want to test that which model basically works the best out of all the 3 4 models you have trained on your training data. So basically what you do is you make your model work on the cross validation or the development data. Okay, and after the comparison you suppose find that the second model that you have made works out to be more efficient on the cross validation set data set, and then you apply this model on the test data set also. So this is basically the function of the cross validation data set, where you only need to test that which of your learning algorithms works best on your data set. Okay, so for small data sets like you have 100 or 1000 or at max say 10,000 examples, where the size of the data set is not very much large, then this ratio of 60 is to 20 is to 20 is very much comfortable for training your algorithm. But suppose that if you have a very big data set, so suppose you have a very big data set where suppose you have 1 million examples. Now, a question to you is that is it much appropriate that you should split your data set in the ratio of 60 is to 20 is to 20? My personal suggestion to this is that I don't think that this is the appropriate ratio in order to split this much big data set. Why? I'll tell you the reason. So the reason for this is that suppose that if you split this data set into the ratio of 60 is to 20 is to 20, then the size of the cross validation set and the test set would be very large. Okay. Also, one thing has to be kept in mind before splitting it into the training data and cross validation and the test data is that you only need the cross validation data in order to test the performance or the compare the performance of your algorithms. So this has to be a quick process. Similarly, when you choose the test data set, the aim of your choosing the test set is that you only need to prove that your results are now unbiased. That is, they do not suffer from high bias or high variance. So this is the only use of cross-validation set in the test set. And you don't need very large training example or a very large data part for the cross-validation set and the test set. So what people generally do, they find out an effective method for the split. So suppose you have a 1 million examples, then what is 1% of 1 million? So it is 10,000. Okay. So I think 10,000 examples are very much appropriate for using in cross validation data set as well as the test set. Okay. Because in cross validation, you only need to compare the models. And in test data set, you only need to prove that that your algorithm is working in an unbiased manner. Okay. So a split of 98% is to 1% is very much sufficient for training this data set. Okay. So what will be 98%? The 98% of the training examples would be allotted to the training data. 1% of examples would be allotted to the cross validation set or the development set, and another 1% would be allotted to the test data set. Okay. I think this concept is very much clear to you because people often make mistakes while dividing their data set into the training data, the cross validation, and the test set. Now let's move to the next slide. So now, one problem that people often face while training their models is that people often make mismatched training and test set distribution. Now, what I mean by mismatching in the training and the test set distribution is that suppose you make an app that generally classifies the picture as a cat picture or a non-cat picture. Okay, so you have an app, and this app basically classifies an image that whether this image belongs to the cat or a non-cat. Okay, so what pictures you take for the training set is that you take random pictures from the web pages for training your model. Okay, but when people often generally use your application, then they take pictures from the Android. Okay, they take pictures from the mobile phones, and using those pictures they generally test that whether that picture is a cat image or a non-cat image. Okay. Now what is the mismatching in this training and test set is that when people often take the images from the web pages, those images are quite much clear and very effectively visible. Okay, so it doesn't need much effort to train the algorithm. But when people take images from your mobile phones or the Android, then the images are of very low quality, and these are the blurry images. And your algorithm or your application often shows wrong results while testing. So this is basically the problem of mismatching that occurs when people generally collect data from different distributions. So what you need to keep in mind is that you need to make sure that the test data and the training data comes from the same distribution. Okay, and I should make a star in this because this is a very important point that you need to keep in mind before taking the training data set and the test data set. Okay, because ultimately what our aim is, we need to take or we need to train our algorithm on the real life data. Okay, and this data should not be taken from the web pages. This should be taken from the real world where this app or the algorithm is really going to be implemented in future. Okay, so make sure that the test data and the training data comes from the same distribution. Now let us move to this slide. Now, one thing that has to be kept in mind is that people often ask that is it a strict rule to follow that you need to divide your data set into the training data set, a development data set, and a test data set? Because what generally amateurs do is people generally don't divide this data set into three splits. They generally use two splits to divide this data set. So suppose that if you have this whole data, this is the whole data, and people generally divide this in two parts. The first one is the training data, and the second one is the test data. Okay. But now, what often people do is they train their model on this training data set, and after applying two, three models, people generally test their models on this test data. So what people are basically doing is that they're using this test data set in the form of a cross validation data. Okay, where they are basically trying to find out from this test data that which model out of all the trained models is working accurately. Okay, and this is a naming mismatch. So people call this cross validation data set often as the test data set, but in reality they end up doing the procedures for the cross validation in this data set. So what I need to say is that it not having a test data might be an okay. So we could only work with the training set and the cross validation set. I hope this much is clear to you. Thanks for watching this video lecture. I hope this video lecture would have been very much informative to you. Like this video lecture. If you have any doubts regarding this lecture, then you can write in the comment section given below. You can share your videos among your community. Subscribe to my YouTube channel. Thank you.